Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 14th, 2025, just yesterday. The core contribution is a new language called Tensor Logic that reduces all of AI to one construct, the tensor equation, unifying neural tensor algebra and symbolic logic by showing that datalog-style rules are just Einstein's summation, plus a simple threshold step. The paper is titled Tensor Logic, the Language of AI. And as we will see later, the implications for model design are quite significant. Beyond the unification, the work shows elegant expressions for transformers and graphical models, natural automatic differentiation, scalable implementations, and even sound reasoning in embedding space that smoothly shifts from deductive to analogical. The previous segment introduced the language and its unifying idea. Table 1 shows how a graph neural network becomes a short sequence of tensor equations, which makes message passing explicit. The neighbor relation defines graph structure, initialization loads node features into embeddings, and an aggregation step collects messages across neighbors. An update mixes aggregated messages with a self-term through a nonlinearity. Finally, simple readouts handle node labels, edge prediction, and whole graph classification. So the previous figure summarized graph message passing, and Table 2 presents the same reduction for a transformer as concise tensor equations. The table walks through input, token embeddings, and sinusoidal positions, then defines a residual stream that carries state across layers. The attention block specifies queries, keys, and values with a softmax scoring, which makes the Einstein summation view explicit. Merge and layer norm combine heads. A two-layer MLP updates the stream, and the output applies a softmax over tokens. Alright, the previous table condensed transformers into compact tensor equations. Table 3 maps graphical model components to the same primitives, which shows probabilistic reasoning sits naturally inside the language. Factors become tensors, marginalization is projection, and pointwise products reduced to joins. A join tree corresponds to a tree-leg program, conditional probability P of query, given evidence equals the program with query, and evidence divided by the program with evidence. Belief propagation, the message passing algorithm that updates local probabilities, is forward chaining, and sampling follows via selective projection. Alright, two takeaways stand out. First, tensor logic reduces learning and reasoning to one construct, the tensor equation, so neural models and logic programs share the same engine. Second, the framework is practical, covering transformers and graphical models, and it enables sound reasoning in embedding space that blends deductive and analogical inference. Thanks for joining. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.